Okay, let's put into action what we just looked at here with our first confidence interval that goes along with a learn by doing on page 158. Is smoking during pregnancy associated with premature births? So a premature birth would be the pregnancy not lasting as long as we expect. To investigate this question, researchers selected a random sample. Random sample, that's good. We need that. Of 100 pregnant women who were smokers. So this 114, that is our sample size. The average pregnancy length for this sample of smokers was 260 days. So since that is specifically talking about the sample, that value is our X bar value, our sample mean of 260. From a large body of research, it is known that the length of human pregnancy, so now they're talking about the whole population, has a standard deviation of 16 days. So standard deviation for a population is sigma. So we've got sigma is 16. The researchers assume that smoking does not affect the variability in pregnancy length. So that's why we can go ahead and, the researchers are assuming that this measurement of variability, standard deviation of 16, applies to our population of smokers. Now, actually, that might be something absolutely worthy of investigation. Does that variability change when you're considering smoking versus non-smoking mothers? But that would be a different exploration. So right now we're going to assume that that standard deviation applies to our population. So A, verify the conditions are met for a normal sampling distribution of sample means. Well, our sample size is 114, which is bigger than 30, so we're good to go, and our sampling distribution of sample means is normal. So in part B, they want us to construct this confidence interval to estimate the mean pregnancy length for women who smoke. Okay, so we've got a normal sampling distribution of all possible X bar values, and we're going to center it over our sample value of 260. So it's centered over our sample mean. And now we're looking for those endpoints, the left-hand endpoint and the right-hand endpoint, to enclose 95% of our curve. Excuse me. So let's just take a look at this over on the side. X bar is 260. That's in the middle. We're going to go out to the right and find the right-hand endpoint. We're going to go back to the left and find the left-hand endpoint. And because this is a 95% confidence interval, we know from the empirical rule this distance is about 2 times our standard error, 2 times our sigma X bar value. So let's see, we need that sigma X bar value. Let me find it down here. So sigma X bar is sigma over the square root of n. Sigma was 16, n was 114. So that gives us a standard error 1 point, let's do 2 decimal places. So 1.50. All right, so the endpoints of our confidence interval then, our left-hand endpoint is 260 minus 2 times 1.5, which gives us an endpoint of 257 days. Our right-hand endpoint is 260 plus 2 times that standard error of 1.5, which gives our right-hand endpoint as 263. So that is our confidence interval. We are 95% confident that the mean pregnancy length for all women who smoke is between 257 and 263 days. Okay, on to part C. Let's also construct a 98% confidence interval estimate. Okay, so the only reason that we could do part B by hand was because they were asking for that 95% confidence level, and we know that goes along with our empirical rule about enclosing 95% of the curve within 2 standard deviations of the mean. But for a 98% confidence interval, we're just going to move to StatCrunch. So we're clicking on Stat first. So for part C, you're going to pick Stat. Now, as you look at your choices over here, proportion stats is what we picked for proportions. We know that normal curves, which we have for means, is always associated with z-scores. So we're going to click on z-stats, and then of course one sample and with summary. After all, we do not have all of the data sitting in front of us. We only have the summary. So just to go back over here, we're picking stat and then z-stats, but I want to be very careful. You only pick z-stats when you have that population standard deviation sigma. You've got to be very careful that the standard deviation you have is referring to the population in order to choose this menu item. On something like pregnancy length, it's probably not that far-fetched that we have an estimate of sigma from previous study. But we do need another way to handle these confidence intervals when we don't have the population standard deviation sigma, because that occurs quite frequently. And that is what we're going to look at in one of our next videos. But for right now, let's go ahead and finish up here. So we put in all the information that StatCrunch asks for. We need our sample mean, which is 260. We need our population standard deviation sigma, which was 16. Our sample size was 114. We're doing a confidence interval, so we're going to click here. Actually, I'm going to leave this set to 95% for just a moment so we can see there's the standard error rounded to 2 decimal places that we calculated, and then there's the same lower and upper limit that we calculated with our rounded off standard error. All right, let's go back. Let's change this to a 98% confidence interval, and there is our answer. So our confidence interval here is from 256.5 up to 263.5. So you can see what happened here. These endpoints, 256.5 is a little smaller than 257. 263.5 is a little bigger than 263, because to enclose 98%, or sorry, 90, what was 98? Yes, it was 98%. Okay, did I do that? Yes. To enclose 98% of the area. To enclose more area, we had to move those endpoints out a little bit. So that's a bit of a bummer, right? Because being more confident in your results, that's great. But then having a bigger interval means that we are less precise than we were with the 95%. So precision is all about how much you are pinpointing that value. More precision is a smaller margin of error, a smaller interval. Less precision, like this one is, a bigger margin of error, a bigger interval. So unfortunately, we increased our confidence level, but we decreased our precision. And of course, the way to combat that is with your sample size. If we could take a sample bigger than 114, we could make the standard deviation smaller, and that would give us better precision. All right, I want to go ahead and move on to 2 right now. Let's revisit the confidence interval applet to just be sure we're understanding the role this confidence level plays here. So, we use the applets not when we can calculate something, but when we want to explore something. So you're never going to come here to the applet to find a confidence interval. That's always going to happen in the stat menu. But we're just looking back on how confidence intervals are constructed. So I'm going to pick applet and then confidence intervals, and this time for a mean. We're going to leave the population distribution. I don't know. Let's do right skewed. It doesn't matter. I just actually want to not pick normal so you can see that it didn't matter whether our population was normal or not. Our mean. Well, here's the thing. If you research length of a pregnancy for all women in general, not just for women who smoke, like was in this example, but all women in general, it's pretty much accepted that it's around 266 to 270 days, something like that. So I'm going to put in 266. Standard deviation we were given was 16. Confidence level, let's leave that set at 95, and our sample size was 114. We picked a Z stats to make our confidence interval. We had the standard deviation sigma. So now I'm going to click compute, and you will see 100 confidence intervals get generated. So this solid line here, that's our population mean that we set to 266. Data varies. So every time we take a different sample, we get a different sample mean. Those are all these dots. Some are to the right, some are to the left. Then from each sample mean, a confidence interval was calculated out to the right-hand endpoint, back to the left-hand endpoint. If that confidence interval caught the population value we were trying to estimate, that confidence interval is green. If it didn't, this X bar was too far left, so we did not catch that population value of 270. Then it's red. So you can see here that we were a bit under. 95% confidence level. We expect over a long period of time about 95 out of every 100 confidence intervals to contain that population proportion. This random 100 happened to come in a little bit under, only 91 out of 100. But remember, probability is not about what happens right now. It's about what happens over a long period of time. So let me reset and try this again. Well, now I've got 98 out of my 100 confidence intervals that contain that population mean 270. I'm thinking now earlier, I might have said contain the population proportion. We did this earlier for proportions, but right now this is all about means. So the straight line we're trying to capture is our population mean. We did that 98 out of 100 times. So our level of confidence is our confidence in our process. It's about, if we did this many, many times, how often do we think our process will yield a good result? But in practice, you're only doing this one time, and you don't know if you grabbed a sample that gave you one of these green confidence intervals that caught the population mean, or if you happen to be unlucky, if a rare event happened and you pulled a sample that produced one of these red confidence intervals that didn't catch your population mean.